try to go through it. So, okay, this guy right here, it's just an easier way of setting up the DAC. It works the same way we've used it before. It's just being it all in one place. We have the number, we have the rate and number of samples, and then we just get our data straight out and put into waveform. The actual processing comes here. It's kind of messy, but basically, okay, for the time, just from testing, I found that if I take the value of I and I divide it roughly by 10, it's about 1 second. And so I use that as my time that's going into there. I use one value to hold the last time that we read a beat. The way we do that, the way we read beats, is we take our data coming in, and there's this thing here called a peak detector. So you set a threshold, and then whenever your wave or your value goes above that threshold, this Boolean value would return true.
So we did some filtering to our signal to kind of invert it so that the peaks of our waveform are pretty consistent, and the real changes in amplitude come from the valleys. So this filtering doesn't change the frequency, but it makes it much easier to read using the peak detector.
Okay, so instead of reading the beats per minute directly, what we do is, the reason why we have all these values here is because we actually take the last three values, the last three time differences, we take the average, and then we calculate the beats per minute, because we found that if we do it every peak to peak, then sometimes you get some erratic behavior, and like if you're a person that's like running and all of a sudden you're, the LED, for example, if that indicates like red, like, oh no, I'm gonna die because, So we want to take an average to kind of dampen those, I guess, that behavior. So these three values are just the last three values that we read. Those go in, I'm sorry, these three. This right here is just a counter. It just counts to 4 so that we know when to reset a counter so that it can take an average. So this entire case structure here just does the averages for us. And that gets outputted to the BPM here. Okay.
Yeah.
So down here.
Yeah, so we already have the beats per minute calculation from what a video just showed us. And so this is a case structure that takes as the Boolean condition, it takes the detection of the pulse in, and it decides what color to output to the cathode. So essentially every time that it detects a pulse, it's going to flash on our LED. And we wanted to detect or produce a color to show what range your heartbeat falls under. So our front panel allows the user to set thresholds for a low, a middle, and a high heartbeat. Typically, the resting heart rate is going to go under the low category. Since this is for joggers and whatnot, you typically want to elevate your heart rate to a suitable level. But there's also a threshold where if it gets too high, it's not really safe. If your heart rate is under a certain level, then we assume that you actually haven't plugged in the heartbeat sensor to your ear, and so it outputs white, which is kind of like an error code, I suppose. And so we essentially have all these case structures determining what range it falls under, and it outputs to this other DAC assistant, which we output through 3 digital ports, and those applied voltages color our cathode.
Yeah, well, actually, we basically just have an array, and whenever the Boolean value is set to false, then its digital output is set to 0, and when that's set to 0, that'll allow the voltage to go through the cathode and basically illuminate our LED in that color.
Right through that color channel.
So, yeah, that's our block diagram. And,
You said you did a digital signal filtering. Which part did you do the filtering?
not digital signal.
Oh, yeah.
No. So, okay, so it'll be easier to show it here. Let me make sure first. Where's that? We hit this guy here. This is our threshold. 2.4 should be fine.
Yeah, we haven't actually changed it. It's always worked.
Okay, so this is just from the last time I ran it, but so here, I'll just run it, I guess, and show you.
Alright, so hook up to my ear.
It takes a bit to like start working, so it doesn't work instantly. It needs like 10 seconds or so.
Yeah, we calibrates itself. My heart rate's probably going to be pretty high due to nervousness from presenting, so just bear with me.
All right, so it's not working right now. It just takes a second.
It's calibrating.
Hold on. There it is.
Yeah, so this is our filtered heart rate signal. You'll see it better once it adjusts.
Hopefully. So one issue we had was that we'd have spikes consistently, and so as you can see, the maximum tends to be fairly consistent, and that's what the resistor achieved actually, because before it would be flipped, and we'd have the maximum going crazy, and we wouldn't be able to set an actual threshold that would catch them all, and so this is kind of what we try to.
Yeah, by inverting the signal.
Should we show it on there on the?
Yeah, just keep it on.
Right.
Maybe Alex, you are nervous? 120 beats per minute.
All right, so let me set this wait a second. All right, so I changed the threshold. 1 second.
Yeah, so you can see the light. It's beating in phase with my heartbeat. Yeah, I can verify that's accurate. And it's red because the BPM that's calculated is fairly high due to my.
And we set the threshold to 110.
Yeah, so right now anything above 110 beats per minute is considered high.
Let me try mine maybe.
So now videos can try this.
Maybe I can get a little bit lower.
Seems more nervous.
Well, I'm not gonna lie, we had a little bit of issues with it, so that's what that was why I was nervous. Hold on, let's get it.
It's calibrating currently. All right, there we
Let's see if it'll. Hold on, it's not 36, I promise. All right. You change the.
Yep.
So now it's beating green, which would fall under normal, and I'm going to change the low threshold just to show you that it will also go blue. So
100.
yeah, so maybe 101. Oh, it dropped. Okay, you can barely see it because it's kind of low, but it's beating blue right now. Anybody see that?
Yes,
Yeah.
I see.
So, yeah, that's basically it.
Okay.
Switch back to this.
Jesse reads the signal. Thank you very much.
Yeah, well, we're done. So, okay.
Well done. Okay, thank you guys. Good job.